Hi class, this is my rendition of what air molecules in a column of air in the atmosphere would look like. Okay, and so this is what we're going to be working off of. And you'll notice right away that the air molecules are not evenly distributed throughout this column of air, that a bunch of them are going to be accumulated near the bottom, and as you work your way up through the atmosphere, you find fewer and fewer air molecules. Okay, so let's take a look at this figure and let's describe it. And I'm going to write some notes on the side. I have to write them sideways, and so I apologize for that. Actually, maybe I don't. Let's do it this way. So the first thing that we need to notice, I'll write it up here and I'll just write as we go down. So number one, we see that gravity acts to compress the atmosphere. So that's the first point we need to make about this figure. So gravity acts to compress the atmosphere. Okay, and so as a result, it's due to gravity. That's why we have so many air molecules located down here closer to the surface. Okay, and so because gravity acts to compress the atmosphere, the second point that we want to make is that gravity acts to compress the atmosphere, so air density is greatest near the surface. Near the surface. There we go. All right. So gravity acts to compress the atmosphere. Anything with mass is going to be acted upon by gravity. And so we often don't think of air molecules as having mass, but they do, obviously. And so gravity is going to act on those air molecules and pull them down towards the surface. And as a result, the density of air molecules is going to be greatest near the surface. Okay. Now these next couple of points are basically saying the same thing. Okay, it's just a different way of saying it. So number three, if gravity acts to compress the atmosphere so that the density of air molecules is greatest near the surface, then the air molecules are more closely spaced. So air molecules, I'll abbreviate here, air molecules are more closely spaced near the surface. Okay. Again, that's just another way of saying point number two. The air density is greatest near the surface. Okay. So gravity acts to compress the atmosphere, therefore the air density is greatest near the Earth's surface. So that's where we find air molecules most closely spaced, is near the surface. And then as a result, the spacing between the air molecules is closest near the surface. And as you go up into the atmosphere, that spacing is going to increase. So the spacing between molecules, air molecules, is going to increase with an increase in altitude. Okay, so again, the higher you go up in the atmosphere, you'll notice that the spacing between the air molecules becomes greater as you go up into the atmosphere. Okay, so the greatest density of air molecules near the surface. As you go up into the atmosphere, that density decreases, and as a result, you have larger spacing between air molecules as you go up into the atmosphere. Okay, and so as a result, Okay, so it's almost like a set of dominoes. So everything we say, this happens because of this happens because of this happens because of this, okay? And so number 5, then the air pressure, since that's what we're talking about in this chapter, we got to relate it back to the air pressure. So air pressure is greatest at the surface, and it's going to decreases with an increase in altitude. Okay, so here's where we come in with our definition of air pressure. That air pressure is the force exerted by the weight of all of the air molecules above a given surface. Okay, and maybe we should go ahead and write that up here. Okay, so air pressure is the force exerted by the weight of all the air molecules above a surface. And that surface could be down here at the surface. Maybe the surface is here, maybe the surface is here. Okay, so the air pressure is the force exerted by the weight of all of the air molecules above a certain surface or a certain point in our column of air here. Okay, and so for example, if we're at sea level, and perhaps we're talking about Houston. Houston's just about at sea level. Okay, so the air pressure at Houston would be the force exerted by the weight of all of the air molecules above a given surface. Okay, so that would be from this point all the way up here. What if we were talking about Omaha, Nebraska? Okay, everybody's favorite vacation destination. Okay, so Omaha, they have a very nice zoo there, by the way, if you ever drive through Omaha. The Henry Dorley Zoo is in Omaha. It's a very, very nice zoo if you ever want to stop by there sometime. Anyway, so Omaha is at an altitude, an elevation of about 1,000 feet. Okay, so 1,000 feet. Houston was basically at sea level. Okay, and so at Omaha, if you're starting out at 1,000 feet, the air pressure is the force exerted by the weight of all of the air molecules above a given surface. So if their surface is starting out at 1,000 feet, then you're automatically starting off with a lower pressure. Okay, and if we go to someplace like Denver, Denver is nicknamed the Mile High City. Okay, so their elevation is 5,280 feet above sea level. Okay, so notice that at Denver, they're starting out way above sea level. Okay, so the air pressure is the force exerted by the weight of all of the air molecules above a given surface. So if your surface happens to be Denver, Colorado, okay, you're starting out at a lower air pressure automatically because there are fewer air molecules above you. Okay, so one more question, one more thing I want to state about this column of air, and it relates to our points here. So gravity acts to compress the atmosphere, so the density of the air molecules is greatest near the surface. So as a result, the air molecules are more closely spaced near the surface. As you go up into the atmosphere, the spacing of the air molecules increases as the altitude increases, or the elevation, take your pick. And then the air pressure is going to be greatest near the Earth's surface because that's where you're going to have your you're going to have way more air molecules above you at that point, and the air pressure is going to decrease with an increase in altitude or elevation. Okay, so the question I want to leave you with that we'll answer on the next one is, I guess we could make this number 6, is the decrease in air pressure constant with a change in altitude? Is the decrease in air pressure constant with a change in altitude? Okay, so that's what we're going to take a look at next. The next video that I make, we'll take a look at that. I think you can see already, because the molecules are not evenly distributed, that this decrease in air pressure as you go up into the atmosphere is not going to be constant. So I can kind of answer that question right away. If these molecules were evenly distributed within the column of air, then yes, the decrease in pressure would be constant as you go up into the atmosphere. But as you look at this figure, okay, with due to gravity acting to compress the atmosphere, pulling those air molecules down so that the air molecules are not evenly distributed within this column of air, then the decrease in air pressure as you go up throughout this column of air is not going to be constant. Okay, that's what we'll take a look at next.